I will say that number 1, there are two different graphs. Some of you got the graph that looks like this, where the y-intercept is at 1. Some of you got the graph that looks like this, where the y-intercept is at 0. I just forgot to make them both the same. So I'll do that one for both of them, and you just write the right one. So for describing the linear transformation, you are looking for steepness, reflections, and if the y-intercept was shifted up or down. So we'll start with the slope. Because it's negative, it was reflected. And the slope is no longer positive 1, it is now 2/3, so that is less steep by 2/3. And then the y-intercept is normally at 0, but is now at 1. So this was shifted up 1. You need all three of those to get that full point. Reflected, the slope is reflected, it's less steep by 2/3, and the y-intercept is shifted up 1. If your graph looks like that. If your graph starts at the origin, the slope is the same, but your y-intercept stays the same. And I just realized I skipped 2, but we'll go back to that.
So good, that one just write y-intercept.
And the slope. You still need 3 things for whichever graph you have, but the slope parts are the same for both. Questions on number 3? I'm going to go back and do number 2, and then we'll do number 5. Number 2 was your slope. We can do that one in Desmos. What was the other point?
That is grade 3.
So if I graph those 2 points, I see they're on a horizontal line, and horizontal lines have 0 slope. Remember that if you're doing this on Desmos, you need to use Desmos, and then your slope is 0. For number 5, this should have been a vertical line, because it's an x, at 1. This would have been a dashed line. I think I can actually make and then this would be shaded to the right. Questions on that one? That one you could have also put in Desmos to double check yourself. And it would have shown you that it's a dashed line at 1 shaded to the right. So make sure you are definitely using Desmos for inequality questions. Great. Does anyone need another SOL packet? Okay. So I want you to write down just answers only for SOL A.3. If you don't have it with you but have it at home, write down the answers on a piece of paper so you can transfer them later. So starting with number 1, 12x to the 3rd times the square root of 3. Notice I'm putting parentheses around what's separate. You don't have to put them, but you can if it helps. Number 2, 4x to the 5th, y to the 8th times the square root of y. Number 3 was just 15. Number 4 was 2 times the cube root of 2, not 2 cubed times the square root of 2. Number 6 was negative 2 times the cube root of 4. 7 was 5x to the 6, y to the 7 times the square root of 2y. 8 was negative 4 times the cube root of 2. I'll give you some time to write that down, and then I'll slow down just a second. Number 5 was 6x to the 4th times the square root of 3x. Number 9, 4x to the 4th, y to the 8th times the square root of 3. And number 10 was the first and last one. When you finish all of those, go ahead to the next page.
Is this like the whole packet of this?
Randomized. If you need me to go back right now. Number 11, the square root of 5, or you can put 1 times the square root of 5. 12 is 12 times the cube root of 9. 13 is 3 minus 3 times the cube root of 5. 14, 7 minus 2 times the square root of 2. 15, 10x times the square root of 5 plus 2, or you can write that vice versa. 16 is 9a squared times the square root of 3 plus 13a times the square root of 3. 17 is 8 times the square root of 15. 18 is 14 times the cube root of 12. 19 is 60. And then I'll scroll down for 20 in just a second. Was 90 times the cube root of 2. So unlike, let's do some Desmos stuff and then I'll get back to that thought. So I'll show you a few of these in Desmos. So similar to the SOL A.3, you can't really do this in Desmos, but you can use it to check yourself. If you need me to go back to this, let me know. Alright, so some of the examples in here, if you were to put in the original with either capital variables or just a different variable, change it to A or something, add in a slider, and change this to something other than 1, -1, and 0, as long as you put in the answer and your decimals match, you know you got that right. If you put in the original and then simplify it, and you put in your answer, the decimal should match. Same thing with the operations one. If you put in the original, put in your simplified answer. If the decimals match, you know you did that right. If it has a variable, you could change the slider to something positive. And then, again, if the decimals match, you know you did that right. So what I started to say earlier, unlike the last two where you didn't really know how to do them, these next, whatever's due next week, you should. So what is due next week is SOL A.3 and A.3. That is something we have talked about, so you should be able to do those. But also double check yourself in Desmos because it is there for you. So those will be due on Monday, SOL A.3 and 4B. And when you need to go back to any problems, look at your course calendar. So some important dates. Remember that you guys are the non-bolded side. This unit is about exponents and polynomials. We'll get into that here shortly. You will have 4 delta maths, 2 due this week, 2 due next week. Your quiz on this is going to be the 11th of March in a couple weeks. And your test that same week. This will be the last test, formatives, all of those for this quarter, as well as the last real quizzes and tests prior to the SOL. Which means after this, to get grades, I'll probably change some of your Shark by answer sheets or some of your SOL things to formative so that you guys have grades. Also, this would be your last flex day until after the SOL, which means if you need to bring your grade up after that, you'll have to come see me after school. Questions on any of that? Yes.
When is your SOL?
I don't. Whenever they tell me. I've estimated it to the end of April, beginning of May, but I don't know. Yes. Yes. Other questions? Okay. Alright, so look at your notes. I'm going to have you guys write in this definition. So polynomials is like this umbrella term that relates to everything we're talking about, but it also means something specific. We'll get to that in a second. This is an expression that consists of many terms. And we're going to rewrite them and write them, and when we do that, they have to be written in alphabetical order with the highest exponent first. So that would be putting it in standard form. We'll talk more about that here in a second. And when we do this, we classify polynomials by degree and number of terms. The degree is the highest exponent, and number of terms you'll see in the table underneath this. We're going to add one thing to one of the tables here in just a second. So when we're talking about degree and highest exponent, if we look at whatever the highest exponent is, that will tell us the degree. So in this example, if I just had 7 with no variables and no exponents, that would be your constant. If I have something with an x but it doesn't have an exponent, that's linear. Something squared is quadratic. Something with a to the 3rd power is cubic. To the 4th is not in this, but if it had a 4, that would be quartic. 5th is quintic. You may see some of those. So degree is based on the exponent, the highest exponent. Number of terms is if I had just one term, that would be a monomial. Mono means 1, so 1 term. Binomial, 2, so any combination of just 2 terms. Trinomial, 3 terms. Polynomial means 4 or more, but it's also talking about all of these. So I'll explain it in just a second. So we're going to try to classify these by the degree and number of terms. So for number 1, what would the degree and number of terms be? Constant monomial. So these are specific number of terms for all of the polynomials in general. So this is technically a monomial polynomial. It's weird. So when you see classified polynomials, it's not talking about specific, the polynomial 4 terms. It's just talking about all of them in general. Right, number 2? Linear monomial, because it has an x. Number 3? Linear binomial. It has 2 terms and it only has x. Number 4? Quadratic trinomial. There's an exponent of 2 that makes it the quadratic, and there are 3 terms. Number 5? Cubic binomial. The exponent is 3, and there are only 2 terms. And the last one. Quartic polynomial. Questions on any of those? Okay, so that's one part of this, being able to classify it by degree or number of terms. The other part is putting it in standard form. So when we put these in standard form, we're looking for ABC order first. So in 7, they all have x's or besides the constant. So we're looking for the highest exponent for the x. That would go first. And then it's going down in decreasing exponents order. So this would go next. And then 1. And then just for practice, if we were classifying this, what would the degree and number of terms be?
Quadratic trinomial.
Yes. I'm just putting that off to the side. Just, it didn't ask us to do that, but just so we're practicing. Okay. Number 8, what would go first? 7x cubed. And then
X squared.
Plus x squared. And then minus x. And then plus 64. And that would be what degree and how many number of terms?
Cubic polynomial.
Cubic polynomial. There are 4 terms. The highest exponent is 3. We're going to skip 9, go on to 10. What would go first?
X cubed.
Negative x cubed. And then plus x. Even though next would technically be something squared, don't put in something that's squared if you don't see something there. And then our plus 24. degree and number of terms. Cubic trinomial. Okay. 11 and 12 are a little different because now we have two different variables. So it's still ABC order. So we would need A first and highest exponent. So A to the third. Then we're decreasing in exponents with A. So then 5A squared B squared. Then we still have something with an A, so 2AB. Now we no longer have any A, so we can do just B by itself. Then if we were to look for degree and number of terms, this one is actually a little weird because this is combined, the highest exponent here is actually 4. So this would actually be a quartic, not a cubic. But it would still be a polynomial. Questions on that one before we do 12? How would we rewrite this in standard form?
5y minus 5y cubed.
So that one would be first. They both have a cube, but alphabetically that wouldn't go first. Jacob.
Negative x.
Yes. Negative x cubed, and then
Negative 7x squared y squared.
yes, negative 7x squared y squared, and then
Plus 5y cubed.
that's where the 5y cubed would go, and then your 13. That would also be quartic polynomial, but I'm not going to read that. So one of your Delta Math that's due on Friday is just classifying polynomials, everything we just did. Questions on anything this related? It would be the x cubed first. Alright, go on to the next page. So now we're going to get into the actual exponents piece. This is going to be a review of stuff we talked about at the beginning of the year. So if we have negative bases raised to an even power, this will always be positive. But we have to use parentheses. Negative bases raised to an odd power will always be negative. So I'm going to give you an example. Let's say we had negative 2, and I raised it to the second power. We know that because we have parentheses, that would be negative 2 times negative 2. That would give us a positive 4. But if we didn't use parentheses, that would be the same thing as saying negative 1 times 2 squared, which would give us a negative 4, which is why we have to use parentheses. But if we have it raised to an odd power, like 3, what is negative 2 to the third power? Negative 8. Because that's negative 2 times negative 2, so a positive, and then times another negative, so it makes it negative. If I didn't have parentheses, what would that give me? Negative. Also negative 8. So it doesn't matter when you have an odd power. You need to keep that in mind for moving forward. But now that we've talked about negative bases, now we're going to change that mindset and talk about negative exponents. They work different. So if I had just positive exponents, I know that 0 squared is the same thing as 0 times 0, and that would give me 0. 1 squared is 1 times 1, which would give me 1. 2 times 2, and 3 times 3. So we know how positive exponents work. Negative exponents is a little different. So I'm going to read this first, and then we'll talk about how to do this. When we have a negative exponent, it changes the base. So we take the base and we flip it to its reciprocal. The exponent goes with it. So if it was up here, now it's down here. And when we flip it, the exponent becomes positive. Magic math happens. That is the rule. Negative exponents become positive when flipped. So if we were to apply that rule to these are all over 1. If I take this and flip this, I have 1 over 0, and the negative becomes a positive. Math magic happens. The rule was applied. But we know that 0 squared is 0, and 1 over 0 is what would that simplify to be? Not 0. Not 1. But undefined. So this one's a special case. And then let's say we did the same thing for this one. Flip this. We have 1 over 1 squared. We know 1 squared is 1. And 1 over 1 is 1. So these two are special cases when it comes to negative exponents. Everything else will work out. So then if I took this and flipped it, 1 over 2 squared, we know 2 squared is 4. The answer we get is really the reciprocal of the positive exponent. So the negative and positive exponent answers are reciprocals of each other. Which means 3 to the negative 2 would be what? 190. Have any questions on how the negative exponents work so far? Okay. Now we're going to do this with variables. But because I don't know what the variable represents, if I were to expand this, a times a, this gives me a squared. So that's not really going to change anything. I did want to mention something about b to the first. Think about all the numbers you know and all of the letters you know. All of those have an invisible exponent of 1. You just don't see it. So all of your numbers, all of your variables have an exponent of 1, even if it's not written. So keep that in mind. So then if I were to take this rule and apply it to this, what would that become? What do you think? What were you saying? So take the base and flip it, make the exponent positive. Yes. 1 over a squared. So then x to the negative 3 would be
1 over x cubed.
d to the negative 1. One over d to the first, or just 1 over d, either or. And then y to the negative 2. Correct. So even though it has variables, don't make that more confusing. The rule is still the same. Take it, flip it, make the exponent positive. All right, questions so far? Go on to the next page. So we talked about the negative exponent rule. Now we're going to talk about the 0 exponent rule. And this is the rule. When 0 is the exponent, the answer is almost always 1. I'm just going to show you some examples where that's not the case. So if this is the rule, the answer should always be 1. And some ways we could find that is, let's say I had 2 as my base, x is my exponent, and I start putting in random numbers into that x. I know anything to the first power is really itself, so 2 to the first is 2, 2 squared is 4, 2 to the third is 8. So really in each of these I'm dividing by 2. So if I were to keep dividing by 2 and go down an exponent, that would make sense that 2 to the 0 would equal 1. Same thing would apply if I have these different numbers. If I have a negative, as long as I have parentheses, that should still work. But then it gets weird when we get to zeros, because 0 to any positive power, this says undefined, but ignore that it said that for 2 seconds. If that same rule applied, then 0 to the 0 should be 0. But I'm going to show you why that doesn't work. So we also know our rule is everything to the 0 power should be 1. And this should be 1, but we just also saw that everything to the 0 power, or 0 to the positive powers is 0. It can't be both. Put in your calculator 0 to the 0 power. It may actually already do that. You get an error. Because it's trying to do both things. It's trying to do 0 and 1 at the same time, so it's undefined. So 0 to the 0 power is a special case. That one's undefined. Also, if we have a negative base, so like let's say we had this one, but we weren't using parentheses, and I raised that to the 0 power, that would give me negative 1. So I want you to write this down. Negative bases raised to the 0 power if parentheses aren't used equal negative 1. So those are your two special cases. If you have a negative base without parentheses, it's negative 1. 0 to the 0 is undefined. Everything else is 1. So if I say, what's 15 to the 0 power? 1. Just 1. If I say 300 to the 0 power, 1. If I say negative a million in parentheses to the 0 power, positive 1. But if I said without, it would be negative. Questions on how negative 0 exponents work? So we're going to do some examples, and then you'll have some time to practice, and then we're going to come back and talk about something else. Okay. So if I said 1.02 to the 0 power, 1. Don't let the decimals confuse you. Negative 2 to the 0 power, also 1. If it didn't have parentheses, then it would be negative 1. So if you want to rewrite that rule from the previous page, anything to the 0 power equals 1. I'm going to put C note about negative bases. Now we're going to do some negative exponent examples where it's more than just one variable or one number. Starting with number 1. So when you see something like this, you have to think about everything is being multiplied together. There are 3 separate things. 4 times y times x to the negative third. Not everything is being raised to the negative third because it's not in parentheses. Then we can start to apply our rules. The 4 and the y wouldn't change or do anything, but the x to the negative 3 can be changed using our negative exponent rule. How would we rewrite that? Once you have everything changed, you want to condense everything back into one simplified fraction. So if you could do that without doing what I'm about to do, that's fine. If you want to see it as a fraction, put 1s underneath, multiply your numerators together, multiply your denominators together. to get 4y over x to the third. That would be the most simplified answer. Once you get the hang of this, all of this in between work you won't need as much. You'll just be able to do it. But as we're practicing, this may be good to separate it like this. Questions so far? I'm going to talk about number 3, and then you guys can choose any you want to see do go over. So in number 3, I have a negative exponent, but it's in the denominator. Right now, the base of this is 1 over w. So if I were to take that and flip it, w is now in the numerator, and would become positive. And this would just simplify to w to the 4th. So as you get the hang of this, you'll notice that if you have a negative exponent in your numerator, or just like this, it's going to get moved to the denominator. If it's already in the denominator, it's going to move up to the numerator. Questions about that? Which of these others do we want to see do go over and have questions about? Okay. Alright, so I'm going to start separating less. So in this one, of the things that need change, 2 to the 5th can actually be simplified to a number. C is not going to change. A to the negative 3 is going to change. It's going to move. And B is not going to change. So we can figure out what 2 to the 5th is. I didn't mean to write that there first. What is 2 to the 5th? So it would be 2 times 2 times 2 times 2 times 2. What do you say? 32. Yes. So then 32C and B are all going to stay in the same place, but A to the 3rd is going to get moved up, and you're going to put that in ABC order. So that would be 32A to the 3rd C all over B. B does not move. It doesn't have a negative exponent. Questions on that one? Right. With 6, there's a bunch of different things that can be changed. 4 to the 3rd, we can actually figure out what that is. We have 3 negative exponents, so those are all going to get moved. So let's figure out what 4 to the 3rd is first. 64. And I'm just separating the things that need moved. Then y is going to get moved to the denominator. 3 is going to get moved to the numerator, and so is z. So I'm going to rearrange that. And I'm going to move this 3 right next to 64. Make all the exponents positive. So now we have all the exponents moved. They're positive, so we don't have to do anything else with that. We can figure out what 3 squared is. 9. And multiply 64 and 9. Someone do that to me here. We have 576 x to the 3rd, z to the 6th, all over y squared. And that would be your final answer. There's nothing else that needs to be changed. What questions do we have about that one? going to give you 10 to 15 minutes to do as much as you can on this page. Some of you may finish before that time and can move on to the next page. Get through at least 15, but definitely keep working if the timer hasn't gone off. You guys can work together on that. I'll be walking around if you have questions on it. After we finish this, after you finish this, we'll go over any questions you have, and then we're going to do start one more thing very briefly, and then we'll be done for today. You said 15.
15 and 6. 15 and 6. Oh. I'm 6 and 10.
Right. Okay, so we'll start at 6. Alright, for number 6, there's only one thing that has a negative exponent, so that's going to come up. The 4 does not go down, the 4 by itself. So this becomes 4 times 4 to the 3rd, and you can do that in your calculator. To get 256. 10 does the opposite. It has a negative, so it's going to come down. And then simplify 2 squared. And then simplify 16 over 4. Questions on those two so far? 15, they both have a negative, so you're really just switching them. You can drop the exponents and then simplify this. Also, if you had put in this original 32 over to the negative 1 over 8 to the negative 1, you would also get that 1/4. So use your calculator, double check yourself. Okay. Other questions? 46 and 51. And then we'll move on. So 46, there are 2 things that come down. I'll do that now. So that would be 8b squared over a to the 3rd c squared. So without really doing any work, showing any work, that would be your final answer. If you wanted to do it individually and change each one and then condense it, you could do that. 51, the m and the p would switch places. It would be 6np over m to the 8. Questions on either of those? Yes. When Mohammed gets back. Okay. Look at the notes I just gave you. I just want to see if you can figure out this rule, and then we'll be done. So in this, let's say I had in number 1 x squared. That would be the same as me writing x times x. And then x to the 4th would be the same as me writing x times x times x. Wait, turn around, please. How many x's would we have total? 6. And then in number 2, let's say I did the same thing. I'm separating each thing. 4 times a times 4 times a times a times a. Then I could rearrange this, put the 4's together, put all the a's together. We have how many total 4's? 2. How many total a's?
4.
And then we could actually simplify 4 squared, which is? So there's a rule when multiplying terms with exponents. Does anyone know or think they know that rule based on what we've done so far? Kind of.
Separate it.
What were you saying?
You have to like separate them to be like fair people together. You know what I'm saying?
So what we're doing is not a necessary step. There's a faster way to do it. Trying to see if you know how to do this faster. So we'll do one more and see if there's a way you can think of how we could do this faster. So if I were to expand this one more time, n times n times 4 times n times n times n times 7 times n. And then I rearrange it. The 4 and the 7 are not the same, but I'm going to move them to the front. And then move all the n's together. So we have 6 n's, and this will become 28. Is there a way I could have figured out that there was 6 n's without expanding it? Adding what?
Count all the n's together.
Yes. If you add up all the exponents of like bases, you get the final number. So that is the rule. When multiplying like bases, you add the exponents. Kind of, but combining what terms could also be subtracted.
Yeah. That's mean.
Let's not totally shut up. Are there any others from this page we want to see do go over, have questions about? I don't need to go.
See, that's one of the unacceptable words.
How do you do
Wait,
so like pick one of the ones that do 4. Okay. So in number 4, the negative exponent happens to be the only one that doesn't have a like base either. So if I'm adding these two exponents, that becomes 6. And then I can just focus on the negative exponent and change it. So we're trying to get away from expanding, but now use our exponent rules. So if I went back into this one, we don't have like bases for the 4 and the 7, but I could have added up all the exponents of n and got the n to the 6. Yes.
How did the C2 on number 4?
That should have been 6. Same thing as the other ones. I could have added 2 and 4 here, added the exponents of 4, and then added the exponents of 1 and 3. Other questions on this page? The other delta math that's due on Friday, we're going to get through most of this in the next class, and you'll be able to finish or do that delta math based on next class. And then you could start it, but you wouldn't be able to completely finish it because there are rules we haven't talked about. But it does have the negative exponents and it does have some of this.